Today we are going to discuss briefly about AI-powered research system designed to automate information retrieval, summarization, and report generation. It uses advanced tools like web scraping and AI-driven summarization to generate structured, in-depth research report in API format. And the input statement include chat prompt template from langchain. It's nothing but it gives a prompt input so that our LLM can understand, and str output parser is used so that any output from the LLM will be converted into a string form, and we are using a wrapper lemma so that we can use our local LLMs which are present in our local system, and we are using a langchain tracer so that we can trace and monitor the activities of the model in langsmith, and we are using importing request and beautiful soup for web scraping, and renable pass through and DuckDuckGo for API search, and archive retriever which is mainly used in document retrieval, and Tably for web searches. It is mainly used in research purpose, so we're using Tably. And we are setting a result per question which is 3, and we are defining our API key, and we are creating instance of DuckDuckGo API and archive retriever and Tably. We are creating function definition. If you're creating a function of web search, named web search, and we are first, what we are basically doing is that first we'll request to Tably API so that it will generate an output. If the Tably fails, then we'll set the output from this as empty, so that we will not get any errors in the further. If it generates any error, also it will not be considered. And the DuckDuckGo will generate research that we are storing in the DDD results, and finally we are returning that result. If Tably results come, that will if we are adding here, and for every result in the DDG result, DuckDuckGo result, we are obtaining a particular links from that, and finally we are returning here. And we are creating API for langchain, and we are defining it, and we are defining a template here. What it basically does is here what we are doing is we are avoiding the hallucinating of our algorithms, and by saying that if any questions cannot be answered in the text, extract the most relevant key point. Nothing but we are extracting only the relevant key points, and not to use not to overcreate based on the input. This was the template, and finally we are passing to the chat prompt template, and we are creating another function called scrape text, which is used to get text input from any website, any URL. If this function take up URL as an input, that if the response is we'll hit a request on that particular URL. If the request is okay, then we'll get we are applying a beautiful soup. Response text will generate raw HTML data, an HTML form that uses inbuilt Python HTML parsers to parse the HTML, and finally we're storing it in a soup. And from that soup we are getting a text, and we're removing the extra spaces and all. Nothing but we are cleaning the data here and obtaining the first 1500 text. If any errors, we will retrieve any exceptions and all will handle here. And we are using deepseek R1 as a LLM. You can use OpenAI also. Due to some reasons and API costs and all, we are ignoring OpenAI. OpenAI performs better than DeepSeek. But compared to that, which is DeepSeek which is open source, it will be better to use in my case. And we are instantiating langchain tracer so that we can monitor our model outputs, and it's working in langsmith. And we are creating a pipeline. So that we scrape and summarize our data. What we are doing basically is we are calling a scrape text function, which we've seen before here, scrape text function. That we are passing a URL. From that URL, we will get a particular text, right? From this function returns text, right? Finally, that text we are finally giving to our models, saying that summary prompt, which is the prompt which is coming from here, and we are passing through our LLM, that is DeepSeek, and we are finally obtaining a string output from the LLM. Finally, with the label of summary, we are displaying it. This was about the scrape and summarize chain and web search chain. What we are doing basically is any input questions we will get from a particular input, any particular question. What we are doing, we are calling this web search. What it basically does is for any question, it will retrieve some URLs for any particular question. That URL we are storing in URLs. and by applying a lambda function. And finally, we are for any input question, we are retrieving documents by applying a retriever, which is archive retriever, which helps us to obtain a document retriever. And we are we are creating a function called get summarizes docs, which summarizes the documents documents from a particular question. And for the clearer understanding and the more precise, we are using this lambda function here. What this lambda basically does is, for any URL, it is like creating a key value pairs, so that for any question, what will be the particular question URL, and it's what is the particular URL, the question, what is the particular question, the doc, and it summarize doc, as I mentioned here. For that, we are applying scrape and summarize text. For this URL, it will scrape the data. For this URL, it will scrape from the particular website, and a particular website, and will return a text it will return a text and summarize for this question. For documents, it doesn't perform like this, because it is not a URL, so that will get any documents or means directly will get that. And we are defining a prompt saying that we'll generate 3 highly specific search queries for any question. We are saying that the queries must be unique, precise, and context aware. And the queries will focus on different aspects of the questions. And the output in the valid JSON list, and we are obtaining 3 queries. And the save JSON loads this function is created so that any output from the LLM model should be handled safely, so that it will not miss the proper JSON replay form. This function basically does that thing. And the search query chain, you are passing the prompt which is coming from here. We are passing through LLM and obtaining a string output from that, and we are calling the function save JSON load, so that we will get a proper JSON output from that. And full research chain. What we are basically doing is search research question. For this pipeline, we are adding for every question. So what we'll get in this question, right? Like we'll get 3 queries from this input. For every 3 queries, we are applying a web search chain. We'll get for every questions. We will get its particular URL and a document. Like that, it will by using map function. Like for every question, we'll get its particular question and URL and its question and its particular related document. Like that, we will get finally full research chain from this output. And we are defining another prompt here. What we are doing is basically in this prompt here, that we are telling our model that we are setting a behavior of the model by saying that you are an AI powered research agent skilled in critical thinking, in-depth analysis, and academic writing. So task is to generate a well structured and data backed report using model formatting. We are defining our template of our research. Like what and all it should contain, like topic, a summary of the findings, and the detailed analysis, and the references, and the notes and all. Finally, we are from chat prompt template, we are finally passing our radar system template, this one, and research report template. Finally, we are showing it in the final prompt. And we are defining a function called collapse list of list. What is basically it is? It will reduce all list form into a. It will take list. It will take a number of lists, and finally it will convert into text form. This was basically this function does. And in final chaining, what we are doing is we are applying all functions that include full research chain, collapse, and collapse of list, and that we are finally passing into a prompt. From that prompt, we are finally passing into our LLM, and from that LLM, we are getting a string output. That we are finally storing in the chain. We are using a langchain so that we can interact with our agent. We are defining our title as a research agent, and this is an advanced research agent powered by Tably, DuckDuckGo, and LangSearch. This was the project. We are running it in a port 800, and the path research assistant will get that particular agent. Let us understand our model by taking with an example. Consider an user gives input like research based input, like what are the latest advancement in quantum computing. The agent takes an input, and it will generate 3 high quality research questions for retrieving the best information. That URLs will be passed to Tably and DuckDuckGo to retrieve prior research information. And from that, we are extracting a relevant content from research result and summarize the findings. For that, we are using a scrape and summarize chain, so that we will get this output from that. And finally, we are using a full research chain. We'll gather and organize, summarize the data. And finally, we are passing it to the final chain, which is present here. From that, we'll get the whole summary, the documentation, the references, the conclusion, and everything. Yeah, from that, we get the whole thing. Yeah, we are now we are going to execute our agent. That includes. It goes like this. Yeah, now we are particular in localhost. We are running on this particular URL. By adding this research assistant playground, we get the particular langchain. Yeah. For this, we are going to get a basic research question, so that we'll get a the question includes like this. This is our question. How will the integration of neuromorphic computing with quantum AI impact the future of artificial intelligence in the field such as medicine, finance, and space exploration? Provide a detailed report. For this input query, our model is going to execute, and it takes a lot of time. Let me show you. It will be running the langchain currently. Currently it is running in langchain, as you can see here. By this we can monitor our any step-by-step process going through our LLM and its inputs, the next pipeline and all. We can monitor those here. Like this, our model is going to give output. Like this, it goes on, and gives a large output so that we can perform our research-based tasks and obtain a final report. And the model finally gave a huge amount of response that include a massive amount of information on the particular query. And as you can see here, like everything, every aspect related to that, like the resource allocation, the advanced material science, everything, the conclusion, the references, as I mentioned, the documents, and it from where it retrieved. That is from IBM, NASA, etc. And the final conclusion. This was the final response our model, which is a very huge. Sometimes some proprietary LLMs fail to give such outputs. This was the model, and you can see in the langchain also. It took around 758 seconds. That is around 12 minutes. Took around 12 minutes to perform this task. Why the time is increasing? So that we are using a local LLM, that is deepseek. My system is not that much powerful of computing that huge amount of information. It is a decent amount of PC, so it takes large amount of time. If you use like API request from OpenAI, it takes a fraction of like 10-15 seconds to perform this task. This was the final output. Like it is from this we'll get this particular output. From this we'll get like the output from this model. The final output should look like this. This was my project, and this is what it looks like in langchain. This was the whole implementation, and thank you.